Well, hello there. Um, Go online and Google Resistor Color Code, and you'll probably find many other tutorials on how to do this. You'll find Resistor Color Code calculators, and you'll find all sorts of useful and interesting information. But seeing as how I'm teaching this as part of BCIT's Technology Teacher Education electronics courses, I figured I'd put my take out on the internet too, because the world really needs another Resistor Color Code video. And hey, YouTube's charging it right. Now, before we start, I want to point out that not every resistor is going to have resistor color codes attached to it. You might get a big behemoth resistor like this one right here. And if I take a look at that one, you can see right down at the bottom right here, it's got 25R written on it. So really, they just got lazy. They didn't put an ohm sign on it. They put R instead of the ohm symbol. So this is a 25 ohm resistor. And somewhere in there, it probably tells you how many watts it is too. I'm guessing this is probably just based on the size of it, probably a 200 or 400 watt resistor. It can turn a lot of electrical energy into heat pretty easily. And in fact, that's mostly what it's used for. This one's going to be used for burning off excess electrical energy as heat. You're not going to see too many of these in your electronics class. You might see some that look like this, and these are 10 watt resistors. So I'm just going to zoom in on here a little bit. And again, they're big enough that they can actually print the number right on it. They actually went and used the ohm symbol. So that's a 40 ohm resistor. And you'll see it also says that it's a 10 watt resistor. So it can turn 10 watts of electricity into heat. So without burning up. Any resistor can do it for a short period of time. These ones are rated to carry on with that. And again, you're not going to be using a lot of those in your electronics class, but if you've got them sitting around, it's good to know that not every resistor on the planet relies on the resistor color code. But most of the resistors that you're going to see look something like this. Tiny little things right here. Now, some of them are really quite small, and these will be our quarter watt resistors right there. There's another one that's a size smaller that's a 1/8 watt resistor, and this is a half watt resistor right in here. So kind of look at them and the size of your fingernail. If they're about the size of your little fingernail, they're probably a half watt. And if they're smaller than that, well, then they're probably a quarter watt. And if they're really teensy tiny, they're probably 1/8 watt. So anyway, those ones are all for most of the printed circuit board projects we're going to do reasonably interchangeable. And all of them have these rings on the side of them that form the resistor color code. And I've got the resistor color code at the side of the screen right now. And I just want to talk a little bit about how you might remember that and how you might teach it and how you might use it in your class. So you'll notice that the resistor color code goes in the order of black. They put white up there, but black, brown, red, orange, yellow. I've got a mnemonic in my head that I'm using to remember this, so it's really hard for me to say the colors as I'm doing them because I'm thinking the mnemonic. And so black, brown, red, orange, yellow, green, blue, violet, gray, white, and then down here, just a little bit separate from that, we've got gold and silver. And we'll talk about gold and silver in a bit because they're a little bit special. So you've got this color sequence coming down here. And for those of you who've done physics and like the color of the rainbow, there's your Roy G. Biv, except we leave indigo off of there because we've already got blue and violet in there. So indigo is just a little too closely fit in there. And what I do with this is I'd have students come up with mnemonics to help them remember the, the, the resistor color code. So they'd have to come up with a sentence that had a different word starting with each one of these. And I sort of made it into a little game, and people would come back, and then we could read them out. sometimes want to filter them before you read them out because kids these days know how to go on Wikipedia and Google resistor color code mnemonic. And you have to spell mnemonic right to do that, right? The M is silent. And so you go on Google and you Google that, and you'll discover that while there's many excellent resistor color codes out there to remember, there's some that really should not be used with your class if you want to maintain your teaching certificate. So anyway, I like a little bit of risqueness to it. And so the one I like to use is bad beer rots are young guts, but vodka goes well. Now, probably if you're teaching grade eights in, particularly in some of our more conservative areas, you probably don't want to be using bad beer rots our young guts, but vodka goes well with your students. So what I'll do with the students is I'll give them a chance to come up with it and I'll filter something out. You can go online and you can find all sorts of resistor color code mnemonics that you can use, and many, many, many of them are suitable for use with your students. Whatever you remember it as, okay, what you need to remember is that the first number is going to be your black, and your black starts at 0. Now, anytime I'm doing this on a test, I always sit down and on the margin of the test, I just go, bad beer, rots are young guts, but vodka goes well. And then I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I make sure that it ends up at 9 because if it doesn't end up at 9, I haven't done it properly. And then, you do kind of have to remember that it goes black and brown, and that down here you've got blue, and that you've got green coming first and gray second. So maybe you could come up with a mnemonic that helps you remember some of those in the correct places. Now, being able to match the color up to the number is really important because this is, after all, a color code. And you'll see I've got a color code waiting for you on the side of the screen right there. Let's take a look at a resistor and see how we apply this color code. So here's a resistor. I'm going to zoom in a little bit on this so that we can see what we're doing a little bit more closely. And just focus on that as nicely as I can. Okay, so what we've got right here is you can see that there's 3 colors, 1 color, 2 color, 3 color, and then a gap. And then we've got this little gold bar, okay? You want to identify that gap because the 3 lines before the gap are the ones that we're most interested in. So let's take a look right here, and I'm just going to move my paper around so I can start at the top of the page. And here I see my first color is red. And then I've got, appears to be a violet. And then a brown in the third spot. Okay, so I'll actually take a look at that and write all that out. Let me just zoom out a little bit so we can see all of my chicken scratch appearing on here. So not all the way there, Mr. Projector, thank you. Right about there. Stop. Stop. I love this camera, but sometimes I want to kill it. It's got an auto zoom on it that zooms all the way in if I hold it down too long. Anyways, you've seen the close-up of that, and you saw the 3 colors and you saw the gap, and now you can see that it says red, violet, and brown right on there. Okay, so now you can take your red and compare it to your chart, and you can say red is a 2, violet is a 7, and brown is a 0. Wait, brown is a 1. Thank you. I'm glad you caught that. Good job. Brown is a 1. Okay, so our number code right there comes out as 271. Our first two digits represent the first two digits of the number. So we get 27. But the third digit goes to scientific notation, and this is 27 times 10 to the 1. So in order to use the resistor color code properly, you need to be up on your scientific notation because quite often there's two places where people choke up. One is with 10 to the 1. People will mistake 271 for just being 1, and they'll tell me that that is a 271 ohm resistor. And they're wrong, okay? Because 10 to the 1 is 10, which gives me a 270 ohm resistor. If that had been red in there, red is 2, it would have been a 2700 ohm resistor because I would have had 10 to the 2, so it would have been 27 times 100. If it was orange, it would have been 27K or 27,000 because it would have been 27 times 10 to the 3, which is 1,000. So it would have been 27,000, and I would have written that out down there. And that's about all there is to it. That final gold line that we saw right on there, so the very last line right up here was gold, that tells me that it's going to be accurate to plus or minus 5%. And most of the resistors that you're going to see in your shop these days are accurate to plus or minus 5%. Back in the day, there used to be a lot more silvers because they didn't have as good a quality control on the production process. So I don't usually worry about that last line nearly as much as I worry about these first three. Okay. Another place where people will tend to screw up on this is that they'll forget that 10 to the 0 equals 1. Okay. So if you see 10 to the 0, remember that you multiply by 1. Another great way to think about this is that the third line tells you how many zeros you add to the number. Okay, so here's another one right here. Let's zoom in on this and take a close up at it. Where are we right here? Come on, camera. Okay, so just looking at that one right there, it looks to me like I've got a blue, gray, and a black. Excellent, that's what I want. And again, the fourth line is gold, and I can tell that's the fourth line because there's a gap between those two. So gold is plus or minus 5%, and we don't worry about that too much, except for maybe some special applications. Okay, so those are our three colors that we've got right in there. Let's zoom out a little bit, see if I can do this without zooming all the way out. There we go. I think I can write with that. So my blue, I looked that up on the color chart, and that is a 6. Gray is, where are we on here? Gray is an 8. And black is times 10 to the 0. Okay, so 10 to the 0 is 1. So what I've got right here is 68 times 10 to the 0, which is 1, which equals 68 ohms. Now, when you're multiplying by scientific notation like this, again, you can also think of it as this number right here as being how many zeros you put after the first two digits. So for instance, with 68, that doesn't mean you put a 0 after the 68. It's 68 with 0 zeros. Okay, so 68 blank, nothing, 68 ohms, or you'll also, as I was saying, see that written as 68R sometimes. It's a lot easier to find the R key on your keyboard than it is to find the ohms key on your keyboard. So there's a couple of low valued resistors. Let's take a look at a couple of higher valued resistors. What have I got right here? Let me just focus on that for a second, make sure it comes through nice and clear. Okay, this one is looking to me like I've got gold at the end right here. Now, if I had it flipped around backwards, you'd know that I shouldn't start reading from that end because you can see the gap right here. Always put the gap off to the right side, start at the left side on here. And so looking at that, uh, well, when I look at it with my eyes, not being distorted by camera colors or anything like that, I definitely see a red and then a violet and then an orange in there. So zooming out a little bit here. Not zooming out that far, please. Yep, educational technology. You gotta love it when it works. Okay, so I've got red, violet, and orange on here. Um, so what have we got on there? So red is going to be a 2, violet is going to be a 7, and orange is going to be a 3. So that is times 10 to the 3 right there. Now, if you're not up on your scientific notation, and yeah, scientific notation, it's all mathy, all you need to do is go 2, 7, and then count the number of zeros that you've got right there. 1 0, 2 0, 3 zeros, and you have a 27,000 ohm resistor right there. Now, if you ask anyone for a 27,000 ohm resistor, they're going to say, electronics noob. We don't talk about 27,000 ohm resistors because we really like our metric prefixes. And so a metric prefix for this one is K, because K is the same thing as 1,000. So if you see a 27,000 ohm resistor, the correct way to refer to that is as a 27K ohm resistor, okay, or 27 kiloohms. You may also see that referred to as just 27K because K is a lot easier to find on your keyboard than K and the ohm key. So there we go. We've got a 27K ohm resistor right there. Let's take a look at something a little bit bigger on here. This time I'm just going to use the mechanical features there and zoom in on that, focus on that if I can. And there we go. So looking at this one, I see blue, I see gray, and I see yellow. Okay, let me lift that up. I think I like the zoom mechanism better, but focus on that. There we go. I've got blue, gray, yellow right in there. Okay, so for measuring this one, we're going to have, let's see, where's our blue is 6. Our gray is, look that one up, 8. And our yellow is times 10 to the 4. Okay, so again, you can say, oh, 10 to the 4 is 10,000, 68 times 10,000, 680,000, or just write it out, 680, 0, 0, 0. 4 zeros, right? No big deal on there. Now, be very careful when you're taking a look at this because you now need to convert that into K because this is 680,000 ohms. So if you say 1,000, just instead of saying 1,000, split it off right there at the 3 zeros mark and say you have 680 K ohms or 680 K resistor. Sounding simple so far? Let's do one more and then we'll take a look at one of the slightly weird cases and then I think you've got it, if you're following along right here. So here's a half watt resistor. Notice it's just a little bit bigger than these other ones that we've been looking at. We've been looking at quarter watt resistors. Here's a half watt resistor, can turn twice as much electricity into heat. And let's just focus on that because it's a little bit bigger. I might not have to fart around with the zoom on here. And what have I got on here? I've got, looks like brown. It's not quite blue enough for blue. Could be violet. I think that one is, it's probably gray. So picking out the actual colors is sometimes a little bit difficult. You do need good lighting and good magnification, especially if your eyes, like mine, are starting to get a wee bit older. So, and then we've got gold on here. You'll notice that we've got two golds. Well, how do we know which gold to use for the precision? Again, it's that gap right there. The gold for precision is sitting up there. That's our plus or minus 5% right there. Okay, and then we've got gold right here. Now, you don't often see these ones. These are really low valued resistors. The first two digits, you do it just like you do anything else. Brown is 1, gray is going to be 8. And then the gold, if you look at that chart, it's actually -1. Okay, so it's times 10 to the -1, which is 0.1. Or instead of moving the decimal place over this way by adding zeros, you move the decimal place back 1 point right here. So what we have right here is a 1.8 ohm resistor. So that's sometimes you'll see that. It's really not that common, but sometimes it pops up where that gold comes in the final band. And if you see a gold or a silver there, it tells you to move the decimal place backwards a little bit. And yeah, it's just as well that you know it's there, but it doesn't happen all that commonly. So that's one slightly exceptional case. I want to show you one more slightly exceptional case, and that is where you've got extra bands on your resistor. Now, 9 times out of 10, 19 times out of 20, even more than that, working in the high school, every case is going to fall into the resistors that I just showed you right there. But if you have a special project and something unique or fancy is going on right there, you may get a resistor like this. And let me just, okay, I'm zooming in on this one so you can see it really clearly. And there you can see we've got extra bands on there. Okay, and you'll also notice that the color of the resistor is a little different. The resistor itself is blue. Sometimes manufacturers will do this to mark out their special resistors. And you'll notice that our last ring, there's a little gap right here. That's how I can tell this is the last ring. I'm reading it this way. So I read all my bands, there's a gap, and then there's my precision on there. So if I was reading it this way, I'd know something was a little bit off because this gap right here is longer than these gaps right in here. And I'd be like, okay, spin it around, read it this way. And what I've got right here is that brown gap is right at the very end. And so what I'm looking at here is I've got a blue, and then I've got a gray, and then a black, and then a gold. Let me just zoom out a little bit here. So I'm going to go. Now, this is still pretty easy to do. It follows the same rules. It uses the same color code, but because we've got a brown on the end, this brown right here indicates plus or minus 1% precision. Okay. And you'll see that you can also get a red in your final strip that would indicate a plus or minus 2% precision. Again, 19 times out of 20, you're going to see a gold strip there when you're working in the high school shops. And 19 times out of 20, you really don't care what's on there. You just care that there's a resistor in there that's probably close to being the right value. So let's just take a look at what we do right here. And we say blue is 6. Gray is, where are we right here? Gray is 8. Black is 0. And then we've got this gold strip in here. And the gold one now is our 10, in this case, to the minus 1. So we've got 680 times 10 to the minus 1, which gives us 68.0 ohms of resistance. Now, we just did didn't we just do a 68 ohm resistor? What's the difference between this one and the last 68 ohm resistor we did? Well, this one, because it's precise enough, it's plus or minus 1%, it's worth saying that it's 68.0. The other one, it's plus or minus 5%. And so 68, you're somewhere between 65-ish and 71. Here, you're somewhere between, let's see, 1% off of a 68 ohm resistor is going to be less than 1 ohm. So you're somewhere between 67 and 69. So it's worth saying that it's shooting for 68.0. So that extra line means you're probably dealing with a more precise resistor, and it's worth giving you more information on exactly how many decimal places are out here. Basically, if you talk about it in math, it would be more significant figures. So that's sort of the resistor color code in a nutshell, summed up fairly easily. And it takes a while to get used to, but it's worth going through and practicing it, because I see students making mistakes on a couple of things that are pretty common, that a student will take a resistor and they will get a 68 ohm resistor mixed up with a 68K resistor. Now, normally, if you're off by just a little bit on a resistor, you're going to have, maybe your circuit's going to blink a little brighter or flash a little faster. Your audio is going to sound a little different, but the circuit will often work if you're off by a little bit on your resistor. But if you're off between a 68 ohm resistor and a 68K ohm resistor, and the only way you're going to tell when that gets into your circuit is the color in that third ring or the fourth ring if you've got a really precise resistor, but most of the time it'll be in the third ring. You're going to see on a 68 ohm resistor that you're going to have a black line there, and on a 68K ohm resistor, you're going to have a yellow line right there. And the difference between a black and a yellow might not make a big difference if it's in the second digit, but if it's in that third bar where you're talking about your exponents and how many zeros you've got, you could be off by a factor of 1,000 or more really easily, and that's going to completely mess up your circuit. So pay attention to what you're doing when you're taking a look at your resistors, and make sure that you measure them out all really carefully. Okay, one last thing. What if you're colorblind? What if your eyes are getting old and you're looking at that and you're holding a resistor up in front of you and Jason, I can't see a thing. Well, don't panic. I know of at least one of our teaching colleagues who is quite comfortably colorblind, has been forever, and leads a full and happy life and teaches an electronics program because he knows that he knows how to teach the color code. He knows what all the words are. He just can't see them. And you know what? There's supportive technologies for all sorts of learning things, and Resistor Color Code is definitely one of them. So what you can do is you can turn on your multimeter, and this is a handheld multimeter, but you've usually got a bench multimeter, and you can dial it in to the resistance that you want to measure. So I come down here and I'm dealing with fairly low resistance values right here, and you can take your test probes and this works really nicely if you've got your resistor plugged into a breadboard or something like that. And there you go. You can see you can get a reading on there. Now that's coming out as 0.06 k ohms. So keep a look at your dial right here. And you can see on the dial you've got different ranges. And right now I'm at the 20 k ohm range because everything I'm going to measure is less than that. Well, we can turn that down and we can go to a more precise range, the 200 ohm range. And let's see if I can't get a little bit more precision on that resistor. 68.2 ohms. So you'll remember this one had 4 bands on it. It was promising to be accurate to within plus or minus 1%. It said it was going to be a 68 ohm resistor. And there we go. It's 68 point, get my connections back on there. 68.2, 68.3. That's a pretty precise and accurate resistor. Like I say, they're never 100% perfect. Let's take a look at a couple of other resistors that we've got on here. They're quite easy to measure. Just set that up like so. This one was our red, violet, orange. So now remember I set the multimeter down to measure a low valued resistor. This time I put my leads on it and it's just got 1. You can think of that actually as the letter I for infinite because as far as it knows, that's infinite resistance because I've got it set into the 200 ohm setting down here. If I turn that up a little bit and go back up to that 20K setting now, I give up a little bit of precision, but I'm still over 20K. So I got to go up one more notch on here. I'm into the 200K ohm, which means that my maximum value I can read is going to be 200 kilo ohms. And you can see that my display right here is showing me K ohms. And I'm going to hit this on here. And now this one is reading 100 and why is that reading 100? Now that one's reading 130 K ohms. It shouldn't be. That seems really high because the first band is red. But you'll notice that the way now that one's saying 127, but our first band right in there is red. So I'm wondering if my meter is wrong or that's a really interesting observation because with that first band being red, that should be a 2 value right in there. Make sure that is red. It's definitely red. Well, either my meter's reading wrong or that resistor has been damaged. I do notice that that one's got the bendy leads to it. So let's check a different value resistor on here and see if my resistor readings are coming in right. Okay, now that one's reading 0. Remember that was the really low one. That was it's got a 1 in the front. It's got the gold in there. Make sure you get your leads on there. And so with the brown out front, that should be a 1. This is taking a while. It's coming down. Okay, so that's a 1. We had the gray in there. So that was going to say that it was a 1.8 ohm resistor. Keep in mind it says plus or minus 10%, so 2.1 is pretty close to being within those specs. Let's see if we've got a high value resistor in here. I think this is my 680k ohm. So I'm going to turn that up. I've got to turn it all the way up to the 2 meg ohm range. Let's test this out on here. Okay, so now you can see it's reading 0.68. So notice though it says megohms. So if it says 0.68 megohms, you've got to be able to translate that back and forth and say that points, get on there, you. I think I've got a glitchy meter here because it was pretty clearly 0.68 megohms just a little while ago. It's coming down. I may not have a good contact on those leads. Okay, well, anyway, good thing we're checking this. I'm going to go grab another meter in a minute. One thing I did want to point out with high value resistors is you're going to be under the temptation to put your fingers onto the test probe like this when you go to do your test so that you can clip on there really well. And with your fingers on the test probe, you'll notice I'm getting a much lower resistance. And the reason for that is when you're dealing with a high valued resistor, keep in mind that your body is a high valued resistor, and now you've put yourself in parallel with the circuit. And the electricity that's coming out right here has a choice. It can go through the resistor or it can go through you if you put your fingers on there. If I remove one finger from right there, now the electricity can't go through me. And there we go. We've got our 680 ohm value or our 0.68 meg ohm value, which is the same as 680k ohms. Well, there we go. I've got a few wonky readings off of this multimeter. I should have used one of our more expensive ones, or I should maybe go and check the battery on this one to make sure that it's all set up and working okay. But the fundamental thing that I want you to take away is I want you to be able to know that resistor color code. I want you to have a mnemonic that works for you for memorizing it. And I want you to have a mnemonic that works for your class for memorizing it. Like I say, bad beer, sorry, young guts may not be the way to start off with your grade 8s, but if it sticks in your head, then I've done my job as a teacher because I love teaching post-secondary. Pause, stop, done, go practice. Read somebody else's video. Check out the other mnemonics that are out there. There's a lot of good stuff, and although it sounds really boring, it's one of those boring skills that if you're in an electronics shop, people are just going to expect you to know what a resistor color code is and how it works. And we're going to use the exact same concepts later on, although without the colors, for reading some of our capacitor values. Some electronic components are just too small and difficult to put numbers on.